So here we're trying to find the derivative of a to the u. So we're still on the derivative of exponential functions. Now what we have looked at before is when our function f of x is equal to e to the x, or f of x is equal to e to the u. So this was the 3.2.23, somewhere like that. And we said the derivative of this, if you recall, was still e to the x, and the derivative of this was equal to e to the u times the derivative of the exponent times u prime. Do you guys remember that? Now these two rules work only for a base of e. Now what happens if the base is not e? Maybe the base is 2 or 3 or 4 or 5 or some, 9.1, which is what this section is about. So here we're talking about a base of a, which is just really any constant. So our f of x is equal to a to the u. So this is our base, which is not equal to e. If it's equal to e, then we just follow one of these two rules above. And actually, let's start with a to the x. And f of x is equal to a to the u. So very similar in the original format of the functions. We previously had e to the x. Now we have a to the x, and we previously had e to the u. Now we have a to the u. The only difference in the derivative of this is that f prime of x is equal to the ln of a. So whatever the base is, we're going to take the natural log of that and times it by the a to the x. Let's just move it over a little bit. So f prime of x is equal to the ln of the base times a to the x. So this is the first rule. The second one says f prime of x is still equal to the ln of a times a to the u times u prime. So the only difference between this and the previous problem was whenever the base is not e, we need to include the addition of the ln of a. Everything else stays the same. So whenever the base is not e, we have the ln of a in that formula. Did everyone get that? Pretty straightforward, I think. But I don't want to make any assumptions here. Let's copy a couple of examples from MyMathLab here. All right, so problem number 1, and there's only, like I said, it's a short section. There's only 10 homework questions here. Well, it depends on what the base is. All right, Myrta, so right, so if we have f of x is equal to e to the x, what is our answer for the derivative of this? E to the x, still e to the x. Now, this is problem number 1 in MyMATLAB, and this 2.6. It says f of x is equal to 4 to the x. Now, is our base e? What is our base in this problem? Our base is 4, right? Which is our a, right? Marta, you okay with that? So this is how we know which one to use, right? It's either E or A, right? If it's not E, then we assume it's A. So because it's A, then we have to include the ln of 4, and then we keep the problem 4 to the x. That's our answer. All right, I'm gonna write the next one. This is number 2 in MyMATLAB. It says g of t is equal to 20 to the t power. And that might not look like a t, but let's write. What is the derivative of this? Anyone else? Faith. What does those two things mean? Ditto? Same? Okay, that's what I thought it meant. All right, so I agree with this. So this is not equal to E, right? So we have to use the rule from over here. So it's the ln of 20, and we keep 20 to the t power. Let's try number 3. It says y is equal to 5x to the 5th plus 1. All right, so I'm just copying the rule and put it down here so we can work on it. Let's see. Right, so this is a to the u because it's not just x. So all of this stuff here is equal to u. All right, so our y prime is equal to, Fate said, the ln of 5, which I agree with, times 5x to the 5th plus 1, which I agree with, times 5x to the fourth. So that's what we did. So we did the ln of the base, then we kept the original function, and we have to multiply by the derivative of the exponent, which is where the 5x to the fourth is coming from. Any questions on this? The last part. All right, let's make sure we're talking about. Are you talking about this part, Martha? Okay. So this is a to the u. Do you agree? This is our u. Are you okay with that? Okay. So our u, let's put it a little bit above here, is equal to x to the fifth plus 1. Now what's the derivative of u for this problem? Five x to the fourth. I agree with you on this. All right, so that's our u prime. So let's look at the formula below. The formula says, clear up some of them. The formula says we have to first multiply by the ln of the base, then times the function itself, and at the very end, if it's a u, we have to multiply it by the derivative of u. So this is our derivative of u, right? This is our a to the u, and this is just the ln of the base. So just to find the derivative of that, we have to do all three parts. The ln of the base times the original function times the derivative of the exponent. All right, let's look at number 4. It says a is equal to 950 times 1.753 to the t power. Or find the derivative of a. Anyone have any ideas on this? No ideas? Faith. ln of 950. Myrta, no. What is their base in this problem? Louis, you think you got it? What do you have? All right, so Faith, you said our base is 1.753. Okay, so that's what we're going to take the ln of, not the 950. The 950 is just a number in front. We're just multiplying it. So the 950 is going to multiply everything. Just imagine the 950 wasn't there, and So how do we find the derivative of this now? Louis, you're probably looking at your problem, right? Not the one we have on here, because your numbers are a little different. But you have the right answer. So it's 950 times the ln of 1.753 times the original function, which is 1.753 to the t power. Faith, you got that? And someone else was, who else? Marta, you okay with that now? Because your original said we're going to take the ln of 950. Okay. Well, let's make a next problem, then I'll go back and work that out. Faith, let's say we had 5 times x to the 4th. What's the derivative of this? (20x to the 3rd). I agree with you on that. Now, how did you get a 20? I'm assuming you took the 4 and you multiply by the 5. Is that correct? Okay, and then you subtract 1 from the exponent. No. So this is 5 times 4 times x to the 3rd. And then you multiply the 5 times the 4 and you got 20x to the 3rd. I assume that's what you did. No. Now let's look at this. This is 5 times x to the 4th, right? Going back to this problem. There's a multiplication in between the 5 and the x. It's just a constant. It is no different on this problem here, right? This is 900 times the 1.753 to the t power. So just like the 5 below, we still have the 950. And we're going to take the derivative of, that parentheses part. Are you following me, Faith? Okay. Yeah, so this 5 is just like this 950. It's just hanging out in the front because of the multiplication symbol. And then we're going to time this by the ln of the base, which is 1.753. And then we're going to keep the original function, which is 1.753 to the t power as our answer. Anyone else have any questions on that? Or let's try this one. This is number 8. Says g of x is equal to x to the 7th times 4.8 to the x power. So that's g of x is equal to x to the 7 times 4.8 to the x bar. What do you guys think? Any ideas on this problem?
Would it be x to the 7th times the ln of 4.8 times 4.8 x?
All right. On the right track. So you're approaching this just like the previous problem. But be careful on this. This x to the 7 here is not a constant. That's a variable raised to a power.
So would you change it to 7x to the 6th?
All right, that's closer to the right answer. One more. So you're on the right track. Did you see what you typed on the comment? She said we need to apply the product rule. Because that's x to the 7th times this. So this is a two-part, it's a product rule problem. The previous problem was not a product rule problem because this is a constant. The 950 is a constant. The 5 is a constant. But because we have a function times in a function, it's a product rule problem. Does that make sense, Faith? Are you there? All right. Do we remember the product rule? So what does the product rule says? If we take the derivative of f times g, very good. This is equal to f prime times g plus g prime times f. All right, so the difficulty here was just remembering that this is the product rule problem. So this could be your f and this could be your g. So let's finish the problem. So g prime of x, according to Faith, we're going to do f prime of x first, which she already told me was 7x to the 6. So that's our f prime of x. Just write f prime for simplicity. Come on. And we're going to times that by g. And our g is 4.8 to the x power. And then we're going to add g prime. And our g prime would be the ln of 4.8 times 4.8 to the x power. And we're going to times that by f, which is times x to the 7th. Oof. So that's our answer right there. Let's write it here. 7x to the 6 times 4.8 to the x power plus the ln of 4.8 times 4.8 to the x times x to the 7th. Louis, come on, it's not so bad. All right, let's try this one. It says g of x equal to x to the 8 all right, how far? Well, that's the whole problem. Are we good, Louis? Can I move? Okay. I think where we're going wrong sometimes is just remembering the rules or which rule to use. Let's leave this problem alone for now. We'll come back to that g of x problem. Let's say we had f of x is equal to 5 times, e to the x power. Is that a product rule problem? Is this a product rule problem? Why not, Louis? What do you think, Martha? Why is this not a product rule problem? It is a constant. This is a constant. So we could actually use product rule on it. It's just going to be much more work. But because this is a constant, we're not using product rule. If we have f of x is equal to x to the 7th times e to the x, is this a product rule problem? Yes. See the difference? This x to the 7 is now a function, so it's not. So we have to apply the product rule to this. How about f of x is equal to e to the x over 7? Is this a quotient rule problem? Well, that's a good answer, Louis. You're not sure. Because we could actually use the quotient rule on it. Just like we could have used the product rule on the up here at 5e to the x. But we do not need to because this is a constant. Right? So because it's a constant, we could actually rewrite this as 1 over 7e to the x and just treat it like a regular problem. How about if we had f of x is equal to e to the x over x to the 4th? Is that a quotient rule problem? Yes, because now we have a function being divided by a function. See the difference, Louis? It's when we have multiple functions that we use product rule and quotient rule. We could use it with constants, but we don't, right? So hopefully this kind of helps a little bit. So let's go back to this g of x problem right here. Is this a product rule problem? Right, so this is a product rule, right? We have x to the 8th, which is a function, times an exponential function, right? So this is a product rule problem. And if you recall, Faith said, I think it was Faith earlier on who said, you know, the derivative. Samira gave the answer, but I think Faith said the derivative of f of x, well, f times g is equal to f prime times g plus g prime times f, right? Samira gave the answer. I'm going to go back and answer in a sec. So this is our f and this is our g. So when we find the derivative of this, first we have to find the derivative of x to the 8th. Right, that's our f, so we're going to find f prime, which goes back to like the first week of class. This is 8x to the 7th. And these rules are not going away. You see this in like chapter 2, you're going to see them again in chapter 3, you're going to see them in chapter 4, you see them throughout the textbook. Right, product rule, quotient rule, chain rule. So this is our f prime of x. So this is what we just did. Now we need to multiply by g of x. And this is just 3.8 to the x power. So that's the second part. Now we're going to add g prime of x, which is our new rule, right? So this is what we learned today. This is an ln of 3.8 times 3.8 to the x power. So all of this is the third part. I'm just going to erase some of this stuff over here. And finally, we had to add the last piece to this puzzle, the fourth part, which is just f, which is the original function, which is x to the 8th. Let's see what Samira had. I know she had answered this. 8.8 x to the 7th times 3.8 to the x power plus the ln of 3.8 times 3.8 to the x. Excellent work, Samira. All right, I want to look at one more problem here. I thought I copied it, but okay, I just put it in the wrong section. All right, so this is actually number 9. An office machine is purchased for $7,900. Assume that the salvage value V in dollars depreciates according to the method called double decline in balance by 30% each year. And the good news is they gave us the formula for this, right? So if it decreased by 30% each year, we only have 70% left, right? Which is why there's this 0.7 here. So, and once again, the 7,900 is the initial value. So it's no different from, you know, the exponential function that we're looking at previously. So what does part A says? Find V of 9. Now, how do we find V of 9? What do you guys think? Plug in for 9, right? This is as easy as, you know, math gets, right? It says 7,900 times 0.70 to the 9 power. Part A, and the question, Luis, is a 3-part question. Actually asks us to find the value after 9 years. Samir, what do you mean? Do we solve? Yeah, we need to find actual value. So what is the value for this? It's a dollar amount, right? So what do you guys get when you plug that into the calculator? $318. Whoa. Can anyone confirm that? All right, thanks, Don. So what is this saying? After you purchase equipment, you know, for $7,900, 9 years after that, piece of equipment. Yes, I said 9. Samir, you okay? Do we multiply by 365? No. The t here in the formula is already in years, so we don't need to convert it to anything. All right, so we probably don't want to round to 1 decimal place since it's dollars and cents. So 318. So after 9 years, this is a value. Let's go part B. Part B says find, let me write out the instructions. Find V prime of 9 and explain its meaning. And this should be meaning over here. So first of all, we know that V of t, let's copy it down here, is equal to 7,900 times 0.70 to the t power. We have to find the derivative. That's what that dash means, right? V prime of t. So once again, this 7,900 is a constant. So this becomes 7,900 times the derivative of this, which is ln of 0.70 times 0.70 to the t power. So that's a derivative based on, you know, like a couple of problems we did earlier. Now it says find V prime of 9. What do we get for this? Negative $113.71. What does that mean? It means that after 9 years, the value is decreasing by negative $113.71 per year. All right, part C says, when will the salvage value of the office machine be half the purchase price? So we know that V of t is equal to 7,900, and that was 0.70 to the t power. So what are we trying to find in this problem? Are you sure, Faith? Close, you're on the right track. All right, let's see. We're trying to find t, right? So this is what we don't know. So they did give us this, right? What is V of t equal to? 3,950. Very good. How do we know that, Don? It's half, right? So we're talking about half the purchase price. So half the purchase price is this. Now, how do we solve this? We're going to divide both sides by 7,900, which gives us 1/2 is equal to 0.70 t. And we can take the ln of both sides. So you're very close there, Faith. So this becomes t times the ln of 0.70 and the ln of 1/2. So we divide both sides by the ln of 0.70. It's equal to t. What do we get for that? $1.94. So after 1.94 years, will be about half the value